All right, welcome back to Mr. P Helps with Algebra. This is Unit 2, Topic 2, Lesson number 10. We've got a warm-up here on arithmetic and geometric means, which is review from a couple of lessons ago. And we've got a lesson that's talking about linear versus exponential models. All right, so we've got a difference of 320 numbers. Now, if there's 4 differences that gets from the start to the end, because that's the first term to fifth term, then that means that each one must be 80. And the reason I know that is because 320 divided by 4 common differences, they all have to be the same, is 80. So this would be 84, this would be 164, and this would be 244. All right, the other way of doing it is with an equation, which would be 4 plus 4 common differences equals 324. And solve it like, let's just solve for the letter D. And in this case, there's a couple ways to solve for geometric sequences. You can multiply the numbers, 324 times 4, and take the square root of that number, and that would go right here. Or, which I believe that's going to be 1236 right here. So this times this, and the square root of that number is 36. Or you can use the equation 4 times the rate to the 4th power, because it takes 4 rates, 1, 2, 3, 4, equals 324. Or another way you could do it is divide 324 divided by 4. Well, this is kind of the same thing as this, and that gives you 81. That's what you would do to solve this. And then ask yourself, what number to the 4th power equals 81? And it happens to be 3. Times 3 is 12. Times 3 here is 108. All right, second question. 3 to 48. We're going to have different numbers in between just because they're different sequences. So this is a difference of 45 numbers. And 45 divided by 4 patterns is 11.25. So that's what you're going to be adding. So this would be 14.25, and this would be 15.5, and this would be 26.75, and that equals 48 in the end. All right, so this one, 48 divided by 3, and that's going to give you 16. And 2 to the 4th power equals 16. If you want to solve it like an equation, that would be 3 times the rate to the 4th power equals 48. And if you solve that equation, you end up getting 2 as your answer. So this is 6, this is 12, this is 24. All right, last question. So this one starts with a negative and ends with a negative. These numbers are 6,240 apart. If you divide that by 4 common increments, I believe that is 1,560, or if it's 1,650. Check my work, so divide this by 4. So I guess I should pull out my trusty calculator, which I didn't have ready. And that would be 6,240 divided by 4 gives me 1,560. So that's the pattern. Add 1,560 all the way across until you get to this number. Keep in mind that they're all going to be negative. The pattern down here, you can do the same process as above. It's going to be divide by 5, which is the same thing as times 1/5. The pattern is times 1/5 or times 0.2. Divide by 5, divide by 5, divide by 5, divide by 5. Yes, you will end up here. I know this one would be negative 50. If you work your way backwards, this would be negative 250. Times 5 again is whatever this is. Okay, so getting to the actual lesson itself. So this is comparing a linear, similarities and differences between linear and exponential functions, seeing which one matches this information better. So this information right here is basically telling you that Calcorama is a company that starts with a $5 million that they've made in 2010. ComputerFest made $2 million. And this one's going to be increasing by $500,000 per year, and this one's increasing by 15% per year. And all you got to do is pause it right here, and you can read the information. It's pretty much the same thing as I just said. So the equation's going to be, I'm going to focus on the explicit equation, not the recursive. Well, you know what? I'll do both. So recursive for Calcorama and ComputerFest. Calcorama is the one that's going to be increased by $500,000. So I'm going to let x equal the years since 2010, and I'm going to let y equal the amount of money in millions. So Calcorama is going to be f of 0 equals 5 million. F of any number is found by taking the previous number and adding a half to it, $500,000. ComputerFest, f of 0 equals 2. f of n is equal to f of n minus 1, and this one is times 1.15, and anything times 1 is itself, so a 15% increase means 15% more than 1. If it was a 15% decrease, you would subtract it from 1, which would be 0.85. And it's a geometric sequence because it's percentage of a number. Of literally means multiply. Write an explicit formula, so that'd be y equals 1/2 per year plus the 5 it started with. This one's going to be y equals 2 that it started with times a rate of 1.15 to the x power. All right, question, homework. I'm going to get straight to the homework here. So we've got two graphs, a linear one and a exponential one. The f of x is the exponential. So all I got to do is come up with some x's. It really doesn't matter what you come up with. I'm going to choose all the evens. -4, -2, 0, 2, 4, and you know what? 6 isn't really going to fit on the graph, but I'm going to use it anyway. So where is f of x at -4? So it's about right here. And if you look at the increments, there's 1. So I'm just going to guess that that's about 0.1. And then the next one is about I'm going to say it's about 0.2. It's kind of hard to tell here. Oh, wait, I was looking at the wrong one. -2 is all the way over here. So that I would say that's about 0.4. 0 looks to be 1 exactly. 2, well, 2, and this is going to be about 2.2. 4 would be about 5 exactly, and then I could just make a guess. Where do I think? Oh, whoop, 4. I went to 5, didn't I? So 2 was 2.2. I agree. 4 was, oh yeah, 4 was 5. I had that right. And 6, which would be about right here, we probably wouldn't hit all the way to up here. 5, 6, 7, 8, 9, somewhere around 9. Now, I'm pretty sure these numbers aren't correct because I didn't really look at them closely enough. I probably should have looked for the actual pattern. But I am giving some pretty good estimates, and that's all that matters for this. -4, -2, 0, 2, 4, 6, same numbers. But now we're talking about the linear one. -4 is obviously 0. It has a height of 0 right here. -2 has a height of 1. 0 has a height of 2. These are going much easier this time. This has a height of 3. 4 has a height of 4. And, okay, did I mess one up here? 2 has a height of 3. 4 has a height of 4. Yep, it's going right. And 6 would probably have a height of 5. And, oh, yep, I didn't mess it up. 0, 1, 2, 3, 4, 5. That seems to make sense. It's going up a half for every one to the right. All right, please give it a like if I helped you out with anything, and definitely subscribe if you haven't done so already. Thanks for watching. Have a great day.